Hello, it is audible.
Yes, sir, audible.
Good evening to one and all present here. Welcome to Atal 6-day online faculty development program on artificial intelligence for environmental sustainability and disaster resilience. Now I request Dr. Aramis Pandian sir, Assist Professor, Civil Department, University College of Engineering, Dindigul, to deliver a welcome address, sir.
Good evening to all. I am very warm welcome to all the distinguished guests, esteemed faculty members, and dear participants gathered here today. It's our great pleasure to welcome you to the 6-day online Atal Faculty Development Program and Artificial Intelligence for Environmental Sustainability and Disaster Resilience. We are immensely honored to extend a special welcome to our chief guest, Professor Sen N. Chan, professor at the University of North Carolina at Charlotte. Your esteemed presence at this gathering is privilege and inspires us all. A heartfelt welcome to you, sir.
Thank you.
Thank you, sir. With great respect, we cordially welcome to our Dean, Dr. S. Sudha from University College of Engineering, Dindigul, to preside over this inaugural function. We thank you for your gracious presence, ma'am. It's also our immense pleasure to welcome Dr. J. Divya, Head of the Department of Civil Engineering, University College of Engineering, Dindigul, to this event. A warm welcome to you, ma'am. Furthermore, we extend a warm welcome to the head of various departments, our dedicated faculty members, and the participants from numerous academic institutions. Last but certainly not least, a special note of thanks to my fellow faculty members whose hard work made this event possible. Once again, a very warm welcome to each and every one of you. Let us all look forward to simulating and productive session. Thank you.
Now I request Dr. S. Sudha ma'am, Dean University College of Engineering, to deliver a presidential address, ma'am.
Good evening to one and all. As our Dean ma'am is in a meeting now, ma'am convey wishes to all of us. On behalf of our Dean ma'am, Professor S. Sudha, I welcome you all for this FDTP programs. Good evening to the destination resource person, dear coordinators of the program, esteemed participant, faculty colleagues, research scholar, and young mind gathering here for this Atal sponsored 6-day online faculty development program on artificial intelligence for environmental sustainability and disaster resilience. On behalf of University College of Engineering, Dindigul, I extend my warm greeting and heartfelt welcome to each one of you. It is really a proud of moment for institution to host a program of such contemporary relevance and social importance. Today we stand at critical juncture where rapid technologies advancement in stressed in with urgent environmental challenges, climate change, natural disaster, resource resilience, and ecological imbalance are no longer distant concern. They are relatives affecting lives and livelihoods across the globe. At the same time, artificial intelligence has emerged as a transformative tool capable of offering innovative, data-driven, and scalable solution for this processing problem. This faculty program designed to equip participants with knowledge and skill that bridge these two critical domains. Over the course of 6 days, a meet expert will really build a device. Themes range from artificial-driven disaster precision and management, smart environmental monitoring, sustainable resource utilization, and ethical implication of developing such technologies. I believe this interaction will not only increase the technical competition, but also instill a sense of responsibility to use AI for the greater good and good of society and environmental. I take this opportunity to thank the AST training and learning Atal academic for their continuous efforts in nurturing faculty development across the nation and for sponsoring the meaningful programs. I also extend my appreciation to the team coordinators and resource person whose hard work and vision have made this program possible. To the participant, I encourage you to actively engage, collaboratively translate the knowledge gained into the impactful teaching, research, and innovation. Together, let us to create a sustainable future, resilient communities, and ecosystem where technology serves humanity and nature in economy. I wish this FTP grant success and hope it creative new ideas, partnership, and contributing towards building a sustainable and disaster resilience in world. Thank you. Thank you all.
Thank you, ma'am, for the wonderful speech. Now I request Dr. S. Prem Kumar sir, University College of Engineering, to deliver an inaugural address, sir.
Good evening to one and all present here. Very good evening to our esteemed chief guest, Professor Sen Yen Chen, and our beloved Dean, Dr. S. Sudha, and our dedicated head of the department, Dr. J. Divya, respected faculty members and enthusiastic participants from various institutions and all present here today. It is the immense pride and great pleasure that I stand before you to inaugurate the 6 days online Atal FDP faculty program on artificial intelligence for environmental sustainability and disaster resilience. We have gathered at a critical stage in our history. Our planet faces unparalleled environmental challenges, from climate change and biodiversity loss to the increasing frequency and intensity of natural disorders. In this era of crisis, we must turn to innovation of new solutions. Artificial intelligence is no longer just a technological marvel. It has emerged as a powerful ally in our quest for sustainable and resilient future. This FDP is designed to catalyze for change. Over the next 6 days, we will explore how AI algorithms can predict extreme weather events, energy consumption, manage waste, manage deforestation, and aid in efficient disaster response and management. Our goal is to equip educators, research, and participants like yourself with knowledge and the tools to harness this transformative technology. We are extraordinarily happy to have with us Professor Sen Yen Chen from University of North Carolina, a distinguished expert in the field, and more experts in the upcoming sessions. We truly grateful for your presence. I like extend my sincere gratitude to our Dean, Dr. S. Sudha ma'am, for his wonderful support, and my special thanks to our HOD, Dr. J. Divya ma'am, for her constant support and excellence within our department. And a special thanks to the Atal team for their hard work in organizing this FDP. A special note for appreciation goes to the organizing team, the faculty members and supporting staff, and hard work have brought this event. Lastly, a big welcome to all the participants. I encourage each one of us to engage actively, ask questions, and collaborate with peers. Let this platform be for forging new ideas, partnership, and had a shared commitment in applying technology for the greater good. I wish all you a truly enriching, insightful, and productive learning experience. Thank you, and once again, a warm welcome to all. Thank you.
Thank you, sir. Now I deliver about our chief guest, Professor Shen Yen Chen, Department of Civil and Environmental Engineering in University of North Carolina at Charlotte, PhD in West Virginia University. He is expert in forensic engineering, environmental disaster assessment, geodisaster assessment, infrastructure assessment using remote sensing, concrete technological innovation. He has published more than 200 technical publications, including 125 peer-reviewed journal papers. Most significant contribution are the use of terrestrial laser and aerial imaging for bridge monitoring. He has 6 patents. He had won various awards, including Indian TKIP Visiting Professor in 2007, Teaching Award for Lee College of Engineering at the graduate level in 2012, National High-End Foreign Export China, 2025 Invention of the Year Award nominated. Thank you. Now, our chief guest will deliver the address and sharing his knowledge. I welcome you, sir.
Thank you very much. I want to thank Dean Dr. Sudaman and Dr. Pam Kumar and also HOD Dr. Tavia for inviting me to give this lecture. May I share my screen?
Yes, sir. You can share it, sir.
Okay, thank you.
Thank you, sir.
The sharing is not turned on, it says. Could you I'm still not able to share my screen.
Sir,
Oh,
now
there you go.
can
Yeah,
share it, sir.
it's going now. Thank you so much.
Okay, sir.
Yeah. Today I'm going to discuss regarding a very, very recent hurricane in United States and briefly about how we apply AI in the disaster event. I wanted to caution, however, that our application of AI only pertain to one particular aspect of this disaster, which is the landslide. So first of all, so this is the outline of my presentation. I will introduce the disaster. I will talk about what is resilience and sustainable development. This particular disaster that I'm referring to is hurricane, or in India you call it cyclone Helene, which happened in September 25 to 27 of 2024. And it happened in my state of North Carolina. And so this week we're celebrating the anniversary of this hurricane. And then I would discuss about how we use deep learning risk mapping of landslides. And then I will also talk about related issue of highway and private bridges that was damaged during this storm. I wanted to present myself as a friend of Tamil Nadu because I have visited Tamil Nadu many times, and especially my good friend Dr. C. Natarajan, whose contribution to the state of Tamil Nadu is tremendous. And I am following his step by trying to be the best educator as I can, and also as much as I can contribute to Tamil Nadu. So this is a tribute to him. But I have today hurricane and all kinds of natural disasters is no longer just a event. It's become a global phenomenon, and furthermore, it's costing a lot of money. So now hurricane or any natural disaster annual globally is $1 trillion business. And this is significant for civil engineers because we have many ways to contribute to this industry. In particular, some of the areas that I have experience in include how do you assess disaster? How do you recover from a disaster? How do you build back stronger than before? And also develop more sustainable design. So those are the goals of engineers towards the disaster we're facing. And our goal is to create a safe, resilient, and sustainable infrastructure that can enhance the quality of life for humanity. That is the American Society of Civil Engineers Code of Ethics. So it shows the societal burdens of civil engineers or engineers, and what we need to do using our skill sets and our talents in improving the society that we're living in. So two very important concepts, resilience and sustainability. So resilience has to do with how well we can prepare ourselves for a disaster and how well we can recover from a disaster. Sustainability is a much long, good term goal. So sustainability wanted to ensure that whatever that we do to recover from a disaster would not harm our future in a broad sense. So, which means that we should not consume so much of our economy that we were not able to prolong our society's future. And also, we have to do it in a way that we're responsible for the environmental impacts of whatever decision that we make. One of the lessons I learned while traveling to India is India use a lot of cement. And the cement is not necessarily a very sustainable material, both for the reason of consuming a lot of limestone and the emission of CO2 through the production process. So it is something that we need to think about, is this something that we can really make a difference? And in the US, we use a lot of wood structures. So even my home is built with wood. And wood, while it's not as strong as concrete, it does have a capability of renewing itself because you can grow more trees. So those are the decision makings that we have while we are moving towards a more sustainable future. One other thing about climate effect is that we are going to see less and less tropical storms, but the more severe storms will result. So this is published by American Society of Civil Engineers. Again, we have been able to predict the disaster levels at different parts of the nation based on climate model. And so what you're seeing here is that you can really take the seasonal effects into warm climates and cold climates, and also determine what is the long-term impact for each one of them. And this has moved into the American structural load design guideline. And so I'm not familiar with Indian structural design practice, but I think the Indian Society for Civil Engineers should and would be able to make your own prediction and projection of what is the long-term impact of climate scenarios in our design code. And going towards sustainability is not just infrastructure or the built environment. It also deals with many aspects of our society, including poverty, including food, health, well-being, education, many factors. This is a projection of the 17 different parameters that we need to take in consideration as we are building towards a sustainable future. And so for all of us, we need to recognize that this kind of goal needs to be built into our design process. So what happened on September 24 to 29th in North Carolina is that we have a unprecedented short distance traveling and yet very strong hurricane that was formed in the Gulf of Mexico. And it is not the first such a short distance travel hurricane. However, it does create a lot of disaster. It generated more than 2,000 landslides. The number here, 1792, was quoted because of our study in December, but since then, many, many more landslides were triggered. And it damaged 79 highway bridges. So for the state, this is a unprecedented storm event that we have not seen in the western mountain side of my state. The picture shows the geographical location of North Carolina, which is on the east coast of North Carolina, and it's one of the states that experienced most of the Atlantic side of tropical storms. This picture shows you the historical tropical storms that hits North Carolina. So you can see that we are not unfamiliar with hurricanes. However, hurricanes that hit the Western Mountain is something that is extraordinary. That has rarely happened in the state. And this is one of the significant characteristic of Hurricane Helene is the amount of rainfall that it brought to the Western Mountains. And the amount of rainfall resulted in flooding, coupled with the more than 2,000 landslides, which contributes to the debris that fall into the flood water. And that makes the flood waters heavy and resulted in all the bridge damages in the riverines. So you can see that Hurricane Helene has an unusual amount of water, that 6 inches is equivalent to maybe more than 30 centimeters of water in a very short time. Okay, this shows you where Helene dumped its water. So the western mountain of North Carolina, we share the mountain range with another state called Tennessee. And as you can see, most of the water were dumped on the right side of the mountain, and this is a critical issue because the east side were not able to. Yes, I do not know who is contributing to the tracks on the screen. I will try to stop sharing and then reshare. Let's see if that will clean up. Okay, good. Thank you so much. And so you can see that all this water has resulted in several areas that were completely flooded. Some areas have experienced more than 10 meters of flood water. And so the impact of this heavy laden debris flow is visible in several of the site images that I'm going to share. Oh, sorry, I'm not able to. Okay, so landslides. There are many kinds of landslides, and including rock falls and circular slope failures and so forth. And in the Western Mountains, what we have typically is what we call a debris flow, meaning it's a thin sheet of slides that has very shallow circular slip plane. And most of the materials that fall into the river or the flood water are very fine particles. And so Hurricane Helene triggered a lot of landslides. This is one of the picture of a landslide. And we documented many of those landslides. For example, here is the same slide that was showing where the slide happens on both sides of the roadway. And there are some one-sided slide, a little downstream from the previous location in Saluda, North Carolina. And you can see this slide is more than I would say more than 50 meters tall, and then more than 15 meters wide. So it's a very large landslide. And then there are some landslides next to the roadways, and that cause the most danger because it will completely shut off the highways, and that caused this event disconvenience to the local residents. Because this is in the mountain range, so the population is not heavy, but once you cut off the traffic, people cannot get out for weeks. This is another landslide, a smaller one in the stream. So we to predict what is the risk of landslide, we use a deep learning algorithm that's embedded in ArcGIS to calculate the landslide risk. This shows you the process of the workflow that we use to model landslide. We use 27 different parameters to make the prediction, which include the elevation of the mountains, the aspect ratios of different topology characteristics, the slope, the rainfall, distance to a fault line, because in the Western Mountains, we have some not significant earthquakes, and then distance to rivers. And then finally, we also use the bridges in valley to determine the impact of landslides to bridges. We use two models, logistic regression model and random forest model. And I will describe in more in-depth of random forest because it's a machine learning algorithm. And then we validate and compare our results with historical data and create the probability of the landslide risk map. We also extend our study because our interest is not only the landslide, but the impact of landslides to highway bridges. So we compare our results to the landslide phenomenon. Most of this study were done before Helene, and so our first publication on the landslide risk modeling was published online in May of 2024. And whether it's fortunate or unfortunate, when September 2024 came along and Helene triggered 2000 landslides, we were able to validate our model with real landslide events. So this is our Western Mountain area, just to show you the geographical significance of what those mountains are. The Appalachian Mountains were formed when the North Continent, American continent plate and the Africa plate separated millions of years ago. And the separation process squeezed the East Continent plate. And so the Western Mountains are young mountains, so they are still growing in height. And the state of North Carolina, hence, is divided into three parts. We have the Western Mountains and the East coastlines, and then the central region is what we call the Piedmont soil, which is predominantly transported materials from the mountains. And so that's what the geographical setting of North Carolina is about. The historical landslides we got is from the Geological Survey, which has a data collection from 1991 to 2021, which totals 4,794 events. To couple these events, we further get additional landslide data from NASA. And so we have a total of historical events from about 6,653 from the same period. And some of those landslide data, we have the polygons in GIS that we were able to actually show the shape of the landslide. Other relevant figures include slope, rainfall, elevation, distance to faults, which is pertain to earthquake, distance to rivers, which pertains to flooding potentials, and then the aspect. The random forest model is an ensemble learning method that use multiple tree decisions to improve the predictive accuracy. So in developing a random forest, we have to take training data set and randomly select the representative training set, and then select the features for modeling, and then finally build the decision tree among the data sets and repeat that process until you create a giant forest of trees. The final prediction is used either in regression or use the classification method to predict all the individual trees. So this is the workflow for a random forest classification. And one of the questions you may come to mind is, why don't you use some deep learning algorithms like neural net? Well, we choose random forest because we wanted to have a comprehension of what the learning outcome may be. And using deep neural network, which is a black box approach, you may not be able to see the correlations, even though it may give a better correlation than random forest. So this is our model validation. As you can see that in our model, the random forest has accuracy of about 82%. We also had logistic regression model, which only has accuracy of 76%. And the random forest is also more sensitive. And we compare the area under the curve, shows that it has 90.9% of saturation. We also compare the receiver operation characteristic curve between logistic regression and random forest. And as you can see for ROC curves, as you are close to the left top corner, as your curve converges to that triangle, your model is better. So on the left corner of this slide, I show you a sample of A is a better fit than B curve than C curve. So in our results, experimental results, we show that the random forest has a better fit than linear regression. Logistic regression. So the outcome of our study is this landslide risk map or susceptibility map, which shows you the different prediction levels. So red means 100% certain of, or 100% most probable landslide locations, and then down to the very deep green areas, which has 0% of or lowest probability. This is all the landslide triggered by Helene. Just visually, you can tell that the landslide locations are very close to our prediction model. And I will show you a better fit curve than this one. But we were able to take all the landslide. We actually, in this particular picture, we only have 1,700, more than 1,700 landslides, because a lot of the landslides are identified much later, probably at the beginning of this year. And we also show location of the damaged bridges of the 79 bridges, and you can see that all of them are one way or the other very close to the landslide location. So there is a correlation between the bridges in the mountain region and the location of the landslides. This is what I was talking about when we overlay the landslide versus our map, you can see that it has a very strong correlation. And I told my student this is unprecedented because most of the study of this nature were able to validate maybe 1 or 2 landslides, and they make predictions of landslides probably for much smaller region. And in our case, we were able to fit more than 1,000 landslides. It's just mind blowing of the results. But when we dive deeper, we take a deep dive into our data and look at the actual correlation, it shows that we have 60% of our prediction are for landslide probabilities more than 50%. And in our figure here, we wrote multi-hazard because we also study the possibility of earthquake and the possibility of wildfire. So one of the critical elements about landslide in the mountain region is that the landslide brought down a lot of trees, and if you don't clean up the trees quick enough, they may become fuel for forest fire. And so those risks are interrelated. And so we try to compare the two, and you can see that the models between having a landslide and earthquake is almost equally accurate as a landslide with earthquake and wildfire. The label below shows LE and LWE. And so this is accumulated function analysis. So it shows that about 50% of the occurrence of the landslides are all close to 60% of the probability of multi-hazard occurrence. So this is very, very significant. If we have less landslides, I would imagine this prediction not as nicely presented as this particular plot. This is another correlation. So we look at all the 27 variables and trying to determine which one is the most critical. And this one is the rainfall, annual rainfall intensity plot. And you can see how it matches with the landslide location. So rainfall is the biggest element in this particular storm. No, not all storms are equal. So there are some storms, the wind force is stronger than the rainfall, and you would see another kind of distribution probably. So in conclusion, our landslide sustainability map has been developed by using machine learning technique for the Western mountain regions. And the predictions show that we were able to identify 100% of all the landslides triggered by Hurricane Helene. Even though not all of them are 100% probable. And the most critical condition factor for the landslide in the Western Mountains are the elevation, slope, and rainfall. I did not show the elevation correlation and the slope correlation, but if you are interested, I can forward you our published paper. Finally, for Helene, the risk map represents a very binary landslide map because Helene is a very unprecedented storm event. And we also learned a few things. So one of which is this is a very long landslide, and we recognize that we may not be able to use the traditional landslide definition, which critically depending on the rock mass at the toe of the landslide. So in this particular case, the circular movements are actually in the mid-span of this particular slide, which is very, very long, more than 100 meters long in length. And as you can see, it's actually constituted of 2 parts because in the middle, there is actually a highway cutting the 2 slides into 2 parts. And so there are many, many elements that come into the play of this kind of landslide definition, which makes the modeling of this landslide event challenging. Next, I'm going to talk to you about the infrastructure assessment. Mostly, we're talking about bridges. So the landslide, as I mentioned, the more than 2,000 landslides dump a lot of soil and trees and rocks into the stream. Yes, I will send the papers to Dr. Tivia and will share with the audience. We actually published 3 papers related to Hurricane Helene, and I'll send all the papers. And one thing that we learned from this particular storm and the damage to the bridges is, one, the bridge damage characteristics are heavily dependent on the level of soil erosion in the region. So this is Chimney Rock Village. As you can see, the right down picture shows the original. It's a very beautiful place to visit in the mountains because it snows almost every winter, and people like to go there for their winter break. But the storm take out most all the buildings that you see in this picture and scour the area. Some of the river beds were extended more than 500 times its original width. So this is a very significant flood event. And the bridge, as we mentioned, bridge location and the landslide locations coincide very, very well. And when we start looking at highway bridges, it shows that most of the bridges have the middle spans. Well, actually, the center piers remaining, but the decks were gone, and so that creates a very interesting. Even for some of the bridge that were not washed out, you can see damages to the abutments of the bridge approach. And this is one of the most significant damaged area in a place called Asheville, and where you can see the bridge almost remains completely intact, but the approach are completely gone. And when we look at the scouring of the approach deck, it goes more than 10 meters into the slab that was scoured out by the storm. So this is a very interesting phenomenon. This is another case where the embankment of or the approach of the bridge were damaged by landslide, but there's no flood in this particular case because this is not a bridge over water. This is a bridge over a railroad. And so what that tells me is the amount of water that washed out from the roadways actually were able to trigger landslides even on a supported or reinforced embankment. So in this case, the retaining wall will completely wash out from the landslide location. This is another bridge that the decks were completely gone, but as I described, the center pier still remains. So we came up with a theory. On the left side of this picture, this is one of our AAC publication that just came out last week. And you can see that the current design of slabs on bridge over water, we typically end the bridge deck to the abutment support. Okay, we think for future designs we should extend the slab all the way into the bedrock or at the embankment site. This will increase more materials, but it actually solves multiple problems, one of which is the bump at the end of the bridge or at the approach of the bridge. So those are the critical questions that needs to be addressed. Then we came across another problem. So a lot of private bridges, meaning crossings for private homes, were washed out. As a matter of fact, more than 7,000, there's a different reports because the state never did a complete evaluation of how many of those bridges were actually gone. There's a conflicting report between 7,000 and 8,000 such crossings disappeared. And so this creates a really, really critical problem because those are stream crossings that built by the homeowners. And so once the bridge is gone, they cannot get out to go food, to get food or get on with their life. So this has been a problem. And because most of those bridges become very expensive to construct, and the state is now mandating all these bridges need to be designed by engineers, not just anybody. So now this is currently a issue that are facing in our state. And all these problems that I just described has something to do with the resilience of the community in the area. So this is a resilience curve published by Zhu and Mustafavi, where you can see that when everything is fine, and then suddenly the storm event happens, you will drop on the performance of the infrastructure. So this is an infrastructure resilience curve. And you take some time for the people to recover after the failure of the infrastructure. Eventually, you have to build back. Sometimes your build back may not match the original performance. Sometimes you can exceed the performance. So there are a lot of strategies and techniques that we are currently investigating to see what is the best way to reduce the recovery rate and the period of recovery, and then make it build back stronger. And which is not easy. And because the storm just happened a year ago, we are still working towards this problem. So this is an ongoing study, if you will. But this picture shows you, if you have a disaster that you have no recovery, then the line will flatline at this very low level. And if we can somewhat recover faster and improve, we actually reduce the pain for people. Another thing is, as I mentioned, resilience is really not just about building the infrastructure. There's a human, societal, and infrastructure interaction in resilience. So we have to learn how do you deal with the resident psychology, well-being, as well as what is the level of community support from the society that can collectively help the area recover. A true recovery cannot be depend on the residents alone. People from the outside need to come in and help. And that's what's happening. This is from Dan Hartig and Hill, published in 2022. We can take individual people's residents' psychological resilience and plot it in the same manner as seen in this picture here. And so, life sometimes give us unusual challenges, such as a disaster or such as losing somebody you love or illness. Okay, so you can imagine it can happen over and over in a person's lifetime. But what does it take to help us to recover from our grief, from our loss, from our challenging feelings about an event that happened in our life is really critical, something that need to be studied. My hope is that more of our students can get involved in the psychological aspects of disaster and not just the infrastructure. This is another presentation in the same publication that shows you if you have a good psychological mental well-being, you will be able to recover much stronger, and that builds in your resilience. Okay, so those are things that still, this is a very new publication, 2022. So this is an area of science that still needs to be investigated and developed. And then there is also similar curve for community resilience. So at UNC Charlotte, my university, we're now working with multiple churches in our area to help the residents to build back their bridges. This is one picture. So we mobilize our students as well as church members, go out and rebuild those bridges for the people who are in the mountains and lost their bridges. And this kind of support is both humane and as well as realistic, because when you physically helping people, that give people a strong encouragement that is just a demonstration of humanity. And that is so important. We need to encourage our students, civil engineers, or all kinds of engineers, to not just stay in the office doing designs. We need to go out and be physical and helping people. Finally, many years ago, Dr. CN took me to Danish Cody. Every Indian remember Danish Cody. And we have to remember, because that is a representation of a community that did not build back. Okay, so the whole community left Danish Cody after the storm back in 1960. And it is a very important lesson learned. We need to know that whatever that we do to help people is the most important thing, because that element itself is a part of their resilience curve. That concludes my presentation, and I think we may have some time for discussions.
Good evening, sir. Hello, good evening, sir. Are you able to hear
I
me?
can hear you well. I can hear you well. Yes.
Yeah, sir, thank you for the wonderful session. And I would like to say that I'm student of Dr. CN, sir. And sir, I have a couple of questions. Like, first is selecting the AI models to for your particular problem. How do you select the models in AI, sir?
Okay, as I mentioned, we choose random forest because it's less computationally rigorous than neural network, and also it's not a black box approach. So you can actually look at the contribution of different variables, and that is usually my approach to AI, to machine learning.
Okay.
Yeah.
Hmm.
We also
Sir,
have been
actually,
using neural net for other applications. Yeah. Go ahead.
yes,
Sorry.
yes, neural networks. Okay. Sir, actually, all these disasters are, natural. So we are building as engineers, we are now generating lot of models and during doing the accuracy and all the sensitivity analysis and all those things. What do you feel about the mitigation of all these effects, sir? Is it possible as engineers, what can we do with this? We are just running the model happened and all those things.
Okay. That's a
In
good
your point
question.
of view, what do you feel that? How do you feel that?
We okay, as I show in this particular example, we build our own AI models. And our university is very, very conservative in our implementation of generative AI. So, like GDP, we do not use them because they will they will not allow us to keep our personal information private. So when you use open or commercial AIs, you have to be careful if they are learning your taking your data, a privacy issue. And so in most of my research, like neural net, we build our own learning machines. I hope that helps.
Yes, but I don't think there is any mitigating effect. Like these models can just help the researchers as such, but as such, we will not be able to resolve the problem, right? Is it so?
It may, it again, it depends on how you choose your parameters. So in one of my group right now, they are trying to take the solutions as part of the learning algorithm and see how the machine can come up with a correlation between the disaster parameters and what can be the solution to the. In other words, now in the academic, there are people who are like us using the AI models to big AI models to create solutions or optimize the solution methods.
Okay. Thank you, sir.
Yeah, I hope I
Sir,
answered your
I have a
question.
question.
Go ahead.
Yeah, sir, be it landslide or flood, these are all based on flow. So, how do you compare the outputs of these deep learning models with the physics-based models like the hydraulic equations and all?
The challenge with the hydraulic equations is most of the time, they are not very good for prediction. And so we have to take other parameters to determine, using deep learning to help us understand their contribution to the landslide. The physics-based models, you need to know a lot about the triggering elements, and that means you have to be able to create like the bedrock levels and so forth, those kind of data. Which in our study is probably more difficult to create. Yeah.
Has any comparison been made, sir, since the AUC ROC curve that you have shown and all? It is with respect to the locations of the landslides that has previously occurred to the model predicted points. So, has any comparison been made with the physics-based models, sir?
No, because I don't think there is a physics-based model for our Western mountains. At least I'm not aware of.
Okay, sir. Okay, okay.
Yeah.
Thank you.
But using historical data, as I showed, we are 90% accurate in our random forest model, or close to 90%.
Okay, sir. Okay.
Yeah.
Thank you.
Any other question, audience? Any other questions? Audible? Hello? It's audible? Audible one?
Yes, your voice is audible.
Okay, okay. Thank you, Professor. Any other questions? Professor? Thank you, Professor.
Thank you very much.
Thank you, Professor. It is very useful and very wonderful for this session, Professor, for us. We are especially grateful and valuable ideas and knowledge you shared with us, Professor. Thank you, Professor.
Thank you. I appreciate everyone for attending this class.
Thank you, Professor.
I'll stop sharing.
Okay, thank you, sir. Thank you, sir. Okay. Dear participants, next session start will be around 7:45 p.m.
Master in Construction Technology and Project Management, another Master's in Soil Mechanics and Foundation Engineering, and PhD in Civil Engineering. Additionally, he obtained a postgraduate certificate in Academic Practice in Higher Education with distinction from Coventry University, United Kingdom. With 13 years of experience of higher education and 1 year in construction field as a quantity surveyor, he is currently serving as tomorrow's leaders representative on the CIOB Hub Committee. He achieved the prestigious MCIOB, member of the Chartered Institute of Building. He is a chartered engineer recognized by the Institution of Engineers, India, and also a fellow of the Higher Education Academy, UK. Dr. Rao has delivered numerous expert talks, chief guest lecture, and webinar, making significant contribution to the dissemination of knowledge in the field of civil engineering and construction material. Now our chief guest will deliver the address and sharing his knowledge, sir. I welcome you, sir.
Hello, ma'am. Thank you so much, Darshini, ma'am. Am I audible?
Sir, yes, sir.
Audio,
Audible,
Mr.
sir.
Audible.
Okay. Because do I need to use any speakers, or if I talk like this, is it audible for you clearly?
Yes, sir. Clearly audible, sir.
Okay. Okay. Thank you. So I don't need to use any other audio devices. Just 1 minute and let me share my screen.
Oh, okay, sir.
Can you please confirm, sir, whether is my screen visible? Yes.
Yes, sir. Visible, sir.
So, yes, sir. Visible, sir.
Okay, so just let me switch on. Thank you so much, sir. Thank you so much for the wonderful opportunity. So I'm very honored to deliver this session in this faculty development program, Artificial Intelligence for Environmental Sustainability and Disaster Resilience. And coming to today's topic is about risk planning and infrastructure development. That's it myself, sir. So thanks for the introduction as well. So here, as it is going to be a faculty development program, so I'm well aware that the faculty members and you might have knowledge, and there might be some senior faculty internet connection. There might be senior faculty as well. So I'm going to deliver this session based on some research we have done and some experiences we have going through infrastructure development, especially here in this Oman and Gulf region. So let us just go through the advancements in risk planning and infrastructure development, and I'm going to create some aware view to understand what are the recent advancements of risk planning and as well as infrastructure development. So you can just go through this. If you can see the risk planning and infrastructure development. So the first question comes in our mind is, what is risk planning and what is infrastructure development? So coming to this point, risk planning and infrastructure development go hand in hand to ensure that, because these are like relative, that's the reason the topic has been decided as both together society brings the societies and better prepared for disasters. If you do it separately, infrastructure development, it goes on developing, and if you don't have this risk planning in hand, so there is a risk, there is a problem that how it is going to handle the rapidly growing infrastructure. So let us see from the basics. What is risk planning? Everybody aware of what is risk of this infrastructure development. So identify potential hazards. This is the first most important. So we all are very much aware that when you are constructing any structure, you will look into all possibilities of floods, earthquake zone, landslide zone, cyclone zone, because the structural design, foundation design also require this information. So assessing their likelihood and impact and developing strategies to reduce risk. So we'll take the information from the last previous years, at least like 50 years, 100 years, sometimes like if it is a flood prone area. So coming to infrastructure development, so designing and constructing physical systems, like we all are aware that roads, bridges, water supply, power housing, and that are resilient, especially that should be resilient, adaptive, and sustainable. So then coming to what is the combined goal of this? So minimized loss. So the loss should be minimized and safeguard lives and maintain continuity of essential services during and after disasters. So these are the basic of this. And coming to the next point, like risk planning involves identification of hazards, assessing vulnerabilities, designing mitigation strategies to build infrastructure capable of withstanding shocks. So these are main uh, areas of it. And coming to infrastructure development, focus on constructing resilient roads. As we discussed, just explanation of the previous slide. So together, what are we aiming is to reduce human and economic losses during disasters, especially ensuring that infrastructure service remain functional. The problem is the infrastructure services remain unfunctional. So there we will have an issue, like we'll have a problems to go ahead. So what is the importance? What is the importance of resilient structures? So coming to important of resilient structures is no longer optional. It is a necessary in disaster prone area, especially in regions like India as well. Any suggestions, or can I hide this somewhere? Or it's not possible. Okay. So coming to the what is the advantage, like why management hazards, and especially can we should remain operational due to costs by avoiding repeated damage and reconstruction, and especially it develops Hello. Sorry, sir, I got disconnected. Hello, sir.
Okay, sir. Okay, sir. Thank you, sir.
Can anybody listen?
Sir, yes, sir. Is it is hearing, sir? No problem, sir.
No issues. We are ready.
It is confirmed, so I can continue.
Sir, yes,
No,
sir.
okay
No
then.
problem, sir.
I'll continue. Sorry for the signal issues. Mhm. Okay, so I'm sharing my screen now. Sir, I'm trying to sharing my screen, but it is. Sir, I'm not able to understand whether my screen is sharing or not. I think now it is sharing. Can you please just check and confirm?
Yes, Professor. It is shared and visible.
Okay, thank you, sir. Okay. Sorry for the technical disturbance. And now we are talking that it will reduce long-term costs and especially related to sustainability development goals as per the industry, innovation, and infrastructure. So it supports sustainable development and strengthens national priorities like Indian National Disaster Management Plan. So, but the best example is like cyclone shelters and raised highways in Odisha have saved thousands of lives during cyclones. So this is what exactly we need, such type of infrastructure which can withstand during this crisis. Then why resilient infrastructure matters in India, and especially why when we are talking about this topic, so why it matters most of the times in India. Maybe for example, if you take this region, so we don't have much rains and we don't have be a disaster, but generally India we have so many areas and so many regions, and we call geography exposes infrastructure to earthquakes, floods, landslides, and cyclones. And resilient features minimizes disruption, protects lives, and reduces long-term costs. And if you see here in Odisha, cyclone shelters and elevated highways reduces casualties during Cyclone Fani, which is like 2019. And coming to Chennai, 2015 floods caused widespread damage due to poor drainage is unplanned urban growth. And coming to such resilient designs aligns with SDGs and Vision 2040 goals for safe, sustainable communities. Like for example, in Oman, we have Oman Vision 2040, and especially they target mostly towards the sustainable development goals of UK. So you can see a map here, so which is generally a landslide susceptibility map of India, which gives you vulnerability mapping and landslide risk assessment. You can observe here in this map, like it shows the zones in Himalayas and Western Ghats, underlying hazard prone areas, and especially this is a map produced by IIT Delhi, shows landslide prone zones across the Himalayas, Western Ghats, and northeastern regions. So now it will help us to understand how it can support AI GIS risk assessment content. Coming to current situation in India, so we have multiple risks because of the rapid urbanization and climate change. So there are some statistics for infrastructure development should be taken very seriously. Coming to challenges, we all are very well aware of these Chennai floods, increasing urban floods in Chennai 2015, in Bangalore 2022, which are recently heat waves and drainage failures due to unplanned growth. And coming to economic losses, so India has lost billions of amounts, especially in 2020 itself, due to climate-related disasters, as per the statistics given by World Bank 2023. Coming to policy responses as well, you see that natural infrastructure pipeline, the smart cities mission, and climate resilient infrastructure plans also have. They're coming up with new policies nowadays. Like I'm giving ideas of case studies because of the time restriction. We cannot consider all case studies to be discussed. But I'm just finding out some case studies, like in 2023, geothermal subsidence in Uttarakhand highlighted the risk of unplanned constructions, especially in fragile zones. So the people who are interested, or the researchers who are interested, so they can consider these case studies, look into their study or research further. So what are the current infrastructure challenges, and why are we having this lecture, or why are we having this session, and why we are focusing more into this disaster management nowadays? So we face structural vulnerabilities due to rapid urbanization. As we discussed here, 58% land mass, especially coming to Chennai, Uttarakhand, and economic burden. So these are all alarming. This focus or attention should be kept towards this risk planning, especially to this infrastructure areas. So this is a basic theory, but coming to our major concept, like how we can integrate artificial intelligence, or how we can integrate this digital transformations or GIS, the technology, in identifying it. So this is the major theme of the faculty development program as well. So from here, we will look into what are the possibilities and how AI or IoT or how GIS can help us to solve these problems. So AI tools such as machine learning, geospatial and analytics, and IoT based very important is that because smart cities are also based on this, like Internet of Things. Nowadays, it is booming like anything because of the development of smart cities. Like everything is like based on internet and connections. And you can see here, machine learning models can forecast probabilities of floods and landslides using rainfall, terrain, and soil data. So these are all possibilities only. Coming into the realities, it depends, like it requires a lot of data. We have to input. Anyways, the natural calamities cannot be always predicted used by machine models, but it can give you abilities only. If coming to GIS combined with AI maps, so this will help because it can monitor the nature as well. When you are giving some geospatial information, some plannings of GIS combined with AI maps can enhance risk assessment. I cannot say that it will never solve the whole problem, or it will give you the impacts of natural disasters, but at least there is a chance of enhancement. So there are so many case studies nowadays. You can start searching into it. Like there is a case study in artificial intelligence in Mumbai coastal roads, like the Mumbai metro projects. They started integrating AI-based flood modeling. So the predictive analytics mapped flood prone zones and influenced drainage redesign. It's all like data interpretation. We call it as the data integration. AI-driven systems optimized pump operation during heavy rainfall, so it measured the impact like delayed flood incidents and reduced metro downtime by 30% during seasonal floods. So the Kerala landslide mitigation, like you are very aware of Kerala landslides. So if AI-based slope stability tools were used to strengthen hillside roads in Kerala, soil and rainfall data were processed via machine learning models to predict slope failure zones. AI-informed material and design choices improved structural resilience, and community input ensured local concerns were also addressed. A strong example of socially integrated planning. So how this AI can help us in real-time infrastructure monitoring. So especially like AI-powered systems with drones, sensors, and CCTV feed real-time health data for infrastructure. So when the data is like we all are aware that when the prompts are clear enough, so AI can give you the best results. The data is like coming from drones, coming from sensors and CCTV. It can integrate the data and it can give you the results. For example, if you take Surat and Gurgaon municipalities, they deployed computer vision platforms to detect potholes or waterlogging or road damage in real time. And coming to these systems enable geotag defect reporting and prioritized reporting schedules. And AI monitoring reduces manual inspection time and also increases civic accountability as well. You can see here just a map how the smart living, smart economy, smart environment, government. So how these are all integrated, how these are all interrelated. So ICT, you know, so how this can bring all together to a successful smart city. So coming to this enabled infrastructure design optimization. So how this AI can help us in enabling design optimization. So as we are all aware that it support planners and engineers by optimizing lines for resilience and sustainability. So nowadays, like when you are going for a new development of infrastructure or any new area is going to develop. So this AI models can help them, like help especially architects, planners, engineering, municipalities. So there is an algorithm material selection reduces embodied carbon in buildings. The structural optimization applies AI to modify designs for seismic and flood resistance include minimized over engineering and reduced maintenance costs. So there are various advantages. So how we can start doing into it. So until now, like we are discussing about artificial intelligence, I would like to listen from other faculty members as well, like before we get into some more details. So what is the current status over there in India, or what is the current status in your surroundings? How this disaster management is being controlled, or what type of mitigation methods you're following over there? If you can give me some inputs from your side so that session can be more interactive and I can also get to know from you, so that the next topics what I am going to explain, I will try to take some examples from your side. So I would like to listen from anyone. If you are interested to please interact. So there, rather than a monotony of continuous slides and explanations, it would be good if we can have some interactions between sharing upon your knowledge as well from that side. Yeah, I'm just waiting that is there anyone who can interact or who can until now, if you have any questions also, please feel free to ask, so which will promote our interaction better, so I can understand what's thought of. Yes, sir.
Sir, what are the mitigation methods followed in Japan, sir?
Sir, we have a case study in further slides in Japan. So unfortunately, I'm not from Japan. I'm from Gulf region. So I can be able to
No,
give.
sir. Japan is vulnerability is more for Japan for earthquake.
Correct, sir.
So how
Correct, sir.
they are preparedness, how the mitigation, prevention, everything they are doing very well. I came to know. So just I want to know what are the methods they are following in Japan to avoid prevent the effects of disaster due to earthquake. Hello, sir.
One Japan case study as well. I'll discuss more into it. Thank you, sir. Appreciate. So that something goes into my mind where I need to focus much. I would like to request from any other participants. So please come up with your questions or anything which you would like to know in further slides, so I can focus more onto it. So no one else? Okay, then. Let me continue further, sir. So as I mentioned, the next slides. Okay. So coming to this in environmental construction, so AI tools improve environmental performance in construction projects, but coming to this monitoring emissions, estimating material waste, and recommending energy efficient alternatives, supporting green certifications like LEED and BREEAM. And there is a case study here. You can see a smart construction site in Delhi reduced cement use by 15% via AI monitoring systems, aligning with Vision 2040 sustainability objectives. Like it is from Singh and Rao 2022 as per their research. Okay, then coming to this disaster resilience planning with AI. So it is increasingly used in planning for resilient against. So from the studies you can see here, early warning system use machine learning models to predict cyclone paths, enabling timely evacuation in coastal Odisha region. So infrastructure resilience simulations evaluate road performance. Community-based planning helps planners integrate local knowledge into AI-led predictions and improved risk mitigation methods. You can see here, this can be, it could be a normal image, but the monitoring nowadays, if you see, CCTVs are also very helpful, especially in our metropolitan cities. The police department or the government are CCTVs, so they're able to immediately respond to the situations. The same way, you can see the future here. The drone has been surveillance. So whenever there is an accident or then anything happens, so the network goes very fast. So this is just the future, how this, as the topic is risk planning and infrastructure management can be handled using artificial intelligence. So coming to here, AI in damage assessment and recovery, how we can be able to get the information about damage assessment and recovery aspects as well. You can see here drone image analysis swiftly estimates building damage in flood affected areas such as Bihar, speeding up relief operations. So drones can be used nowadays, the places where humans cannot reach, the drones can reach, and especially the drones are very helpful for surveillance. Coming natural language processing helps analyze citizen reports and media posts to prioritize intervention zones as well. And government uses Uttarakhand floods. So AI assisted mapping enable rapid deployments and improving response times. So here, post-disaster, like not only before the disaster, so after the, because as we said, like it cannot be controlled anytime, the nature. So if, for example, if it happens after the disaster, so what type of recovery is accelerated by AI techniques? So then vulnerability mapping with artificial intelligence and GIS. So when this both integrated together, this combination enables accurate mapping of vulnerable zones. For example, urban flood maps created using satellite imagery and deep learning. So landslide suspectability mapping predicts high risk slopes in Himalayan regions as well. So there is a case study. You can use this case study in your learnings. AI GIS mapping in Pune's urban planning project. Like who are interested to do any projects or include this in your teaching and learning process, try to look into this Pune's urban planning project, reduced exposure to flood zones by influencing zoning and construction permissions. So smart maintenance and asset management, like ongoing infrastructure health is maintained by AI. How it is? Sensors and most of the time like predictive analytics, tracking bridge stresses, road wear and tear, and water pipeline leaks in cities like Surat and Jaipur. So this can be monitored or this can be maintained. So detection of flags like red flags, like early stage damages, and automate repairs, work orders. So the outcomes can be like municipalities, they can report preventive maintenance, the cost, because when we are able to identify these type of damages in early stages, so we can be able to have reduction in the cost of maintenance, and as well as the service lifespan can also be increased. So coming to case studies, there are so many case studies which are available, like smart city initiatives. One type of case study is like Ahmedabad and Pune. They showcase AI-driven smart city infrastructure. So they have this AI integrated systems managing traffic congestion, water usage, and energy demands. Like it's all about like when the data is coming, so it will be integrating the data and giving the results, like where is the traffic congestions and where are this water usage more and less and any energy demands. So these type of disaster readiness tools alert officials to floods or heat waves in real time because of the geospatial data availability. Coming to this Pune's water management AI platform. So because these leaks are identified, so any leaks are identified or predicted, or because of the cracks being developed or because of the material damage, if there is any prediction happens, obviously it can reduce the loss. This Pune's water management AI platform showcased the water loss of reduced the water loss of 18%, so demonstrating public utility resilience. We can see here what is a smart city. We're all talking about what is a smart city, like how much the budget allocated to the project and total number of cities, the basic criteria for selection, if it is a city or municipal area. So how we can implementation of governance and Swachh Bharat missions, publication of newsletters. So there are so many things like track records. All this the information can be used to turn a city into a smart city. So why these metrics are very important? So because of using these metrics, you can be able to evaluate system performances and impacts of AI. So the first thing is like structural integrity score, like SAS, we call it as like measure of strength and durability, disaster recovery time, so time taken to restore essential services during the crisis or during the post-disaster, environmental impact index, how much is the carbon footprint and ecological impact indicator. So these AI platforms use these metrics in predictive models, and these used for optimal performances. So then this is one of the preview of the smart city, like how the sustainability is monitored. through waste management, we monitored using traffic management, parking management. So how people like smart digital signages, coming to the efficiency, the smart street light system, the biometric payment access control. So now it's all becoming artificial. So as we this could be some little bit interesting because of this in real case studies, the role of artificial intelligence in risk assessment, how these satellite images, sensors, and IoT will help us to identify hidden risk patterns. AI analyzes huge data sets. Machine learning models predict flood zones, and sometimes it can predict landslide prone areas or earthquake impacts with higher accuracy. So this AI-based risk mapping helps governments also allocate to resources proactively. There is a case study available like Google riverine floods up to 48 hours in advance, covering 360 million people. So these type of alerts or these type of predictions can help, especially the human loss, or we can be able to take preventions or preventive measures, or at least reducing or mitigating the risk. So how the AI early warning systems helps. So AI first of all integrates with the weather forecast. So generally we have 1 month, 1 week of weather forecast. We are able to see this how the cyclones are turning around and how this natural disasters are coming. So when this AI integrates to this weather forecasting system, it will provide us with real-time sensor data for alerts. And coming to this fast detection of cyclones, like yes, we have very high range of predictions nowadays in cyclones, especially during rainy seasons, monsoon. Nowadays, we are able to predict what type of impact it is. So they divide zones into different types of zones, and government takes remedial actions immediately. Tsunamis and heat waves as well. So this will help reduce casualties. This is the majorly important. The human loss can be controlled or reduced through timely evacuation planning. So, sir, you were asking about this Japan's earthquake early warning system. So we have this EEW in Japan. So they uses artificial intelligence and they use seismometer data. So they alerts millions within seconds, reducing infrastructure and human loss. I would like to tell you one example as well here in Oman also. So all our phone numbers are integrated to this Royal Oman Police. So we have done a trial as well. So whenever there is an emergency, all our mobiles get an alert from the government saying that it will come like a siren in our mobile. So maybe, for example, if any area has any flood coming, so that area all covering that network zone. So all those mobiles will be flashed with this whatever the message they want to, or evacuation or be alert. This type of systems are developed here. So this can control the loss or control or alert the people at least. So as you said regarding this Japan, so as is correct, like it is having a very high, well-developed risk planning and infrastructure management because of its exposure to frequent natural hazards. There are so many hazards happening, not only one particular type. There are tsunamis, volcanic eruptions in some areas. So there are so many case studies which you can look into how they meet. Not only from nowadays, like they have earthquake resistant infrastructure, this policy from 1995 itself, like what they have learned from this and how they are going to handle it in further. Like especially in case of Tokyo's country also, they have lot of central column damping technology. And coming to tsunami defense infrastructure, in 2011, they have taken a lot of post-disaster measures, reconstruction of coastal sea wells, or evacuating raised evacuation routes. Especially the smart monitoring systems are helping them a lot, like offshore sensors, real-time alerts to residents. So there is an example here in Kamaishi city. to reduce tsunami force. Like this, in Japan, they have flood and typhoon risk management. They have learned lessons from previous disasters, and they're identifying the area, and then they're coming up with this risk management. And even volcano risk management, they have how to reduce the disaster risk reduction. They have come national level policies, which we are going to discuss in previous the coming next slides as well. So they always come up with engineering solutions. They make policies and regulations. They are, as we are very much aware, their technology is being very advanced. So the integration of technology, community engagement, and then coming to the, especially as I said, the major point is like they continuously learn from mistakes, or they learn from the lessons, and they'll take up how it can be in future, how they can control it. And coming to the in India also, we are having, now we are advancing towards bridges or dams. You can see here predictive maintenance collapse and extends assets life. So coming to this AI monitoring on Mumbai's Bandra Orly ceiling, the real-time vibration monitoring for safety during monsoons. According to the vibrations, if there are any abnormal conditions or abnormal signals, immediately the responsible team, emergency response team, gets into action, and they look into the possibilities, and they have their own mitigation methods or response systems. So coming to the simulation models, like AI creates virtual models of disasters like digital twins for cities. So nowadays, if you might have heard about this, the digital twin is a very advanced technology, enables testing of resilience strategies before the real disasters, useful for planning evacuation routes and emergencies, shelters, as we discussed in previous slides about Odisha had this type of emergency shelter and critical infrastructure. So here is another example of a case study, which will help us in doing research on these topics, like Singapore's virtual project, which is AI-powered 3D city model for disaster simulation and resilience planning. If anybody is interested, please go deep into it. So it might help us in writing papers or articles, or at least using it as project case studies. Coming to this climate changes, like how this can be helpful in climate changes, like heat waves, because nowadays of global warming, so we are facing more heat waves and sudden rains. Even in summer, we had so much of rains this time, urban storms. So as we understand, the resilient urban design is equal to, if we have a good flood barrier, or if we have a permeable pavements where the water doesn't struck on roads, if we have a smart drainage systems, so then we can call it as a resilient urban design. Because this is the major issues, like even for example, like I'm from Andhra Pradesh, so I have seen this Hyderabad area and Visakhapatnam areas. So it has a lot of drainage issues because of non-permeable pavements, or because of struck of waste materials in the drainages. And when we don't have this flood barriers, so there is a challenges for this resilient urban design. So maybe this AI can help model urban growth, especially disaster risk simultaneously. So people from Chennai can understand this Chennai Smart City flood model. So in AI predicts rainfall, flooding, hotspots, integrates into city planning. So there is a Kerala flood case study, which is in 2018. So it experienced the worst floods in 100 years. A poor dam risk planning, inadequate. There is a movie as well on this 2018. Poor dam risk planning. It comes to inadequate early warning, major losses. So when you have this AI-based predictive water release models, could have reduced disaster scale. Like, so this is a in that situation, how this AI can be integrated. If AI might have been there, what type of damage could be controlled. So as per the statistics, it says that over 400 deaths and 1 million displaced more than 5.4 billion dollars estimated damage can happen in this Kerala floods. Coming to this buoy earthquake in 2001 in Gujarat, the magnitude of 7.7. So it has a lot of damage happened. But why we are talking about these case studies now? So how this can be further controlled? Like for example, highlighted the need of resilient building codes plus AI seismic risk prediction. So Cyclone Fani in 2019, Odisha. So AI could enhance cyclone tracking and shelter planning. So according to this data, it's all about like data integration. So Odisha's disaster preparedness per early evacuation saved thousands. So this is how this technology or AI could be included into this situations. So there is a global study. So again, Japan earthquake and tsunami in 2011. So this is how they had a 9 magnitude is a very huge, like generally 5.6, 5.7 or 7 itself having a huge impact. So that had 9.0 earthquake magnitude. So this tsunami and Fukushima nuclear disasters. So how this can then they started resilient infrastructure like tsunami walls, earthquake resistant buildings, and they saved lives. But AI could have improved nuclear plan risk management as well. So this is how this can be integrated. In simple words, IoT is like Internet of Things sensors monitor water levels, seismic vibrations, and building health. And coming to this AI plus IoT is equal to smarter, faster disaster response. Example like smart flood sensors in Ganga Basin, data shared with NDMA, Natural Disaster Management Authority. There are so many policies should become like as we discussed. So the Japan had policies, other countries have different policies. So what is the governance role? So the Natural Disaster Management Authority should lead India's policies. So how this AI integration can be nowadays it is at a pilot stage. So because we are just learning it, so that requires government, industry, academia collaboration. So do a lot of research, how it can be. So take some case studies from established countries, or if Japan has already implemented it, so we can consider it as a pilot stage. So how we can align with our framework and how we can align with United Nations sustainable development goals. So what is the future? Like how the future of AI in disaster management comes in. So AI will enable hyper-local climate forecasting and integration with blockchain for transparent relief distribution. And this is the time where we multidisciplinary like management department, logistics department, or blockchain, computer science, the smart resilient infrastructure. This can reduce losses. As per the statistics, it can reduce at least 30 to 50% of the loss. We are able to properly manage this disaster using AI in future. But as we all are very much aware, and you might be having so many questions, what is the practical possibility? Yes, we are talking like we are discussing that AI can do this, AI can control this, and what is the practical possibility? The major failure could be from the data gaps, especially in remote areas. So there might not be having such accurate data. Coming to high cost of AI infrastructure development. So we are all very much aware of the current government scenarios, the government situations. And in these situations, are they really able to implement this high cost infrastructure deployment? And coming to ethical issues nowadays, everything like we are getting excited about AI, and immediately we are getting into data privacy issues and AI being biased, or ethical issues are there. So especially we need how to use it. We have the engineers, we are all conventional method followers, and we are just getting into these technologies. Not everyone, on average. Coming to this, we need skilled professionals in disaster technologies as well. So there are so many huge challenges in front, and there are limitations as well. So to make it in short, how we can conclude it is like always risk planning plus resilient infrastructure is the key to saving lives. If you have risk planning separately and if you have infrastructure, so it should be resilient. Resilient means like we can say that how to act in some on spot, like in situ, like on spot, how we react to that, how our emergency response team reacts to the situation. So this AI provides predictive insights, smarter monitoring, and faster recovery. And then coming to this, India must integrate artificial intelligence in natural disaster strategies to achieve goals of resilience and sustainability. Coming to this, it's all collaborative, like not only private sector, public sector, not only government. So it's a collaborative effort, like government, academia, industry. So we all look into this research and possibilities. Then there is a long way forward where we can integrate this risk planning and resilient infrastructure leads to safe infrastructure management. So this is from my side, and hope I have given some awareness of use of this artificial intelligence into risk planning and especially into risk planning and infrastructure management. So now it's up to you. Like if you have any questions or if you would like to have any discussions or any interactions, please feel free to interact. Is there any questions?
Sir, what is the role of NDMA, National Disaster Management Authority in India?
Sir, thank you, sir, Dr. P. Shabarnath, sir. Sir, that is the major authority which looks into all disaster managements, right? So in particularly this, they should look into the policy making and especially they should be able to do some pilot studies because a change cannot happen within a few months or few years. So they should start maybe like they can take one particular prone area and they start it as a pilot study, get from the experiences like kind of like Japan or UK, US, if they have these management systems. So get some support or bring them here and do the study and especially how the data integration could be done. So if they are able to do this, like we can come up with some solution because what happened in Japan, it might not happen here because of the size, number of people, the data accuracy, the technology we have. That's what we were discussing, that the challenges and limitations are very high actually to make this happen. But I think the success the government of India or the Indian technology has been successful in implementing this IoT, the smart cities. So Internet of Things are being placed well. So the smart cities are being developed nowadays, and hopefully we are able to get into this type of risk planning using this AI as well. The major role of them is to have this policy decision making bodies should come into and they should look into the implementation. They should start like pilot study and start implementing. Is there any question in the chat? No, thank you. I said it would be good like if you're able to ask some questions and interact. So at least you can share like whatever I can also learn from your side. So anyone would like to?
Sir, thank you, sir. Any questions from the participants? or shall we wind up the session, sir?
Okay, sir. I'm just waiting for any questions from participants. If they have no questions, like thanks for the opportunity, sir. Anytime, like if anybody have any questions, also feel free to contact me so that I'll try to address their questions as well. We can also have some collaborative research if they're interested.
Sir, I have a question. Can I put
Yes,
forward? Yeah, it's like myself, Sundari. I'm working as a professor in Coimbatore College, and my students and my base area is artificial intelligence. And my students is
Great.
right now taking up a project in disaster management, like flood management. So, in which we are just not connecting because after a flood arrives or so, how the person who is inside the area can contact the rescue team without any internet or the connectivity. So could you help in that kind of aspect?
Thank you so much, Professor. And ma'am, the question what you have been asking is like it is much related to your computer technology as well, because that is what we are expecting. We have SOS calls in mobile phones, which doesn't require any type of this one. So without the person, because sometimes person might not be able to contact. So that time we require this IoT sensors or drones or any management systems, like where the information should be passed to ERT. I understand your question, ma'am. That is what like we are trying to have this collaboration between this civil engineers and especially professors like you from computer science platforms working on AI. We should need to get into some sort of solution, ma'am. So to if you are asking me personally, like I have only information about this SOS
Right
when there is
now,
an
sir, right now we is like studying up only a low range. Can you able to hear me, right, sir?
yes, ma'am. It's very clear. Your audio is very clear.
Yeah, it's like right now we were studying it with the range of the sensor is very, very low, sir.
Yes, ma'am.
Like we can pass only the message 10 to 20 meters. So if you could get us with some kind of sensors, how we can just, put forward the signal can be transmitted or some. So we can just use AI to
Correct, doc. Regarding this
predict it more, but he doesn't
normal
know
service.
how.
Yes, sir. Rather than artificial intelligence, how about the service of normal telephone signals of SOS? Doesn't work?
Sir, it doesn't work. Sir, it doesn't work. SOS when
Ma'am, sorry, your
you
voice is
just give
suddenly
it
dropping
doesn't
and
work in the volume is suddenly dropping. Sir, in our phone, SOS message will be dropped out when you are not having this tower connection, sir. It is not working.
Okay.
So at the time of flood, because we were working only on flood disaster management, how we can just pass this information to an rescue team that these kind of persons are there or some kind of. So we were like only able to pass the signals around 10 to 20 meters. That
Correct,
is we.
ma'am. Maybe in this situation, it should be only through satellite communications. Maybe electronic people can help us, like in the situation, like how the satellite communications can be taken.
Yeah. Okay, sir. Thank you so much. And if you could come across it, we'll have a
Yeah,
collab.
sure, ma'am. Because I'm not into this type of technology research area. I cannot answer you on the spot. But what I understood is like I have heard about this satellite management systems. Like even though no signal is available, they can be able to it. And I will also look into this, and I'll get back to you, ma'am. Thank you so much. And I'm also looking forward to for this type of collaborations.
Thank you, sir. And I was like very interested in when we're talking about this disaster that is avoiding it. That area was wonderful, sir. Where AI can do the predictions because here we just in the AI we just use only uh, the stimulated data because as we don't get any number of data to train it, but we use stimulated data. But I just wanted to how all the parameters we are not confident about the parameters. You just said that about how the statistics can be given to us regarding the floods and that can be avoided beforehand. That was a wonderful session, sir. Thank you so much.
Thank you so much. Thanks for all your interaction. Thanks a lot.
Sir, any other questions, sir, from the participants?
Yes, sir. It would be good. Like I'm very much interested. Like if they're able to interact, if they're able to ask some questions, it will give us a nice ending to the session. Okay, sir, then hope I'm able to deliver the session to the best possible. And if they have any questions, please feel free to let me know, sir. So I will try to find solutions. Like, is there anything which I can do? Further collaboration, we'll do it. Thanks for the opportunity, Prem, sir.
Okay, sir. Thank you very much, sir, for your wonderful session, sir. Thank you, sir. Thank you. Thank you, all the participants. Tomorrow we can join at 6 p.m. Sir. Thank you. Thank you all.
Sir, I'm leaving.